Today we start the last section of the year. Can you believe it? We're down to about 2 weeks of school left. Those of you who have been working hard and checking in most days, thanks. I totally appreciate it. You've been doing a great job. Keep it up. We're almost there. So, our last section that we're going to be working on is geometric sequences. We were working on arithmetic sequences last, and in an arithmetic sequence, you added to get the next term. In a geometric sequence, you multiply to get the next term. Now, in arithmetic, you could add a positive or add a negative. In geometric, you can multiply a whole number, multiply a fraction. You can also multiply by something that's going to flip-flop the signs. And so we'll talk about that as well. So let's just start. When you look at your geometric sequence, you want to look from term to term, and some of them are going to be more obvious than others. So what I notice here is if I multiply 4 times 3, I'll get 12. Is 12 times 3, 36? And if I'm not sure, I can just plug it in my calculator and see if it is. Also, if I'm not sure, what I can do is I can take the two terms next to each other and I can figure it out by doing 12 divided by 4 and see what I get. Oh, I got 3. That must mean that I multiplied 3 to get 12, so I'm going to check to see if that's my next one. So if I wanted to expand this, if I wanted to get the next term, I would just have to take 36 times 3 to get my next term on this, 108, because each time I multiplied by 3. Like I said before, you don't always have to multiply by a whole number. You can multiply by a fraction. And so it looks to me in this next one like I'm cutting it in half, which means I'm multiplying by a half. And so when I look from term to term, again, I'm going to be multiplying by the fraction a half. And you could also use zero point 0.5 if you wanted to. Um, and again, if I can't see it, I would take this 6 divided by 12 and see what I come up with. Oh yeah, 0 0.5. That's the same as a half. And then as I move from term to term, I'm going to keep mine in fractions. So I would do 3 times 1 half. If you did 3 times 0.5, that's fine. But my next term here would be 1 1/2. Or depending on your calculator, it might write it as 3 halves. Or if you did a decimal, it might show up as 1.5. All of those are absolutely acceptable answers. It's just you have to find the pattern that's going on. Now, when I move on to a problem like the next one, you do have to be a little bit careful sometimes. This one isn't incredibly obvious to me. What I notice here is 7 times 2 is 14. And again, if I did 14 divided by 7, I would find that, yeah, 2 is that difference between there. So now I have to check the next one. Is 42 divided by 14 also 2? No, it's 3. Or I could check, is 14 times 2 equal to 42? And nope, it's 28. So this next one looks like it is times 3. That means this here is not geometric. It could be arithmetic if I add each time, but that doesn't even look like it's arithmetic because that would be plus 7, and it certainly is more than 42 when I add 7 again. So this is not geometric, not arithmetic. This is neither geometric or arithmetic. And on your assignment today, you're going to have to answer, is this arithmetic, is it geometric, is it neither? I want to do a slight change on this next one because I want to do an alternating sign here, just so you can see that in action. If I start off with, let's make this first one -3/4, then +3/16, then -364. Now, when I look at this one, again, it's a little bit different and it can be a little tricky to look at, but one thing I notice is that the signs are changing. So if the signs are changing, that means I must be multiplying by a negative number each time. So times negative something. The other thing I notice is that the numerator, or the top number, is staying 3, but the bottom is the one that's changing. Because the numerator is staying as 3, it's going to be multiplied by negative 1 over something. Now I just need to figure out how that bottom is changing. So I'll just look at the 16 and the 4. 16 divided by 4, what do I get? 4. So it looks like that one's multiplied by negative 1/4. Is 16 times 4 64? Sign is changing again, so it's definitely times a negative again. 3 stayed the same, so definitely 1 on top. So the bottom is what I have to look for. Is 64 divided by 16 4? Yeah, it is. So it looks like it is times negative 1/4 each time. So now when I want to move on and find my next term, I'm going to take what I have here. I'm going to put it in fraction form because my calculator uses fractions. If yours doesn't, you can do it differently. You could do it just separately. It's going negative, positive, negative. So definitely the next term is going to be positive. I've noticed that the 3 remains, and I can just work with the bottom. I'm multiplying the bottom by 4, so that would be times 4, 64 times 4 on the bottom. Or, like I was going to do, I would use my fraction key, so I'd do negative 3 over, remember we have that fraction key that we learned how to use. If you don't have a calculator like this and you have to use your phone, you're going to have to do a different method. But negative 3 over 64, I'm going to times negative 1/4 because that's what I'm multiplying by each time, and then I'll get my answer that way. So this is 3 over 256. So 3 over 256 is my next term, times negative 1/4. But keep in mind you're multiplying each time. So then my last problem that I have here, the last one we're going to go through is 13 to 23. And so try as I might, I can't come up with something that I multiply 13 by to get 23. So I'll do 23 divided by 13. And oh boy, that came out ugly. So I'm going to suspect that this is not geometric. And so if I look a little bit closer at it, maybe you're already noticing it, but if I look a little bit closer at it, I see that I'm actually adding 10. Okay, there's the pattern. So my next term, if I added 10, would be 43, but this is arithmetic, not geometric. So you're going to see geometric, arithmetic, and neither. Um, Good luck. I hope all goes well. Have a great Thursday, and we will talk soon.